Thousands of feet below the surface, the deep ocean is cold, dark, and under extreme pressure. There is no sunlight, very little food, and almost no margin for waste. That is why deep-sea animals often look so extreme. Their bodies are shaped by scarcity, darkness, and the need to survive with maximum efficiency. In this video, we are looking at how deep ocean conditions shape the animals that live there, and why so many of them evolve oversized teeth, glowing organs, transparent body parts, and low-energy hunting strategies. The deep ocean begins where sunlight starts to disappear. As you descend, blue light fades, heat falls away, and the water turns into a cold, pressurized void. In the midnight zone, there is no day or night in any human sense. There is only darkness. Food is scarce. Movement costs energy. Visibility is almost zero. That changes everything. Animals here cannot survive by being ordinary. They have to become efficient, deceptive, and sometimes grotesque. Every body plan is shaped by the same basic pressure. How do you find food when almost nothing can see? Few deep-sea animals capture that nightmare better than the anglerfish. Its most famous feature is the lure, a glowing organ that hangs in front of its face like a living baited hook. In total darkness, even a faint point of light can pull in the curious, the desperate, or the doomed. And that is the genius of the anglerfish. It does not waste energy on long pursuits. It lets the darkness work for it. It waits, it glows, and when something gets close enough, the mouth opens and the trap is over almost instantly. The body itself looks built for one terrible moment. A huge head, a loose stomach, teeth like needles that angle inward so prey cannot easily escape. In the deep sea, hunting is not always about speed. Sometimes it is about patience, so extreme it becomes a weapon. That is why the anglerfish matters. It is not just visually shocking, it is a near-perfect example of how the deep sea rewards low-energy ambush hunting over long pursuit. Then, there is the fangtooth. It is not a giant animal. In fact, compared with many surface predators, it is relatively small. But its teeth are so oversized that they cannot fit properly inside its mouth without special pockets near the brain. That alone tells you what the deep ocean demands. When prey is rare, you do not evolve for comfort. You evolve to make every opportunity count. If food appears once in a long stretch of darkness, you need to hold on. The fangtooth is a reminder that in the deep sea, proportions stop making intuitive sense. Bodies become all-function. Every feature is exaggerated toward survival. Nothing is elegant by surface standards. Everything is efficient by deep-sea standards. This is where the deep ocean stops feeling random. Each creature looks shocking on its own, but the pattern is simple. When food is rare, every useful feature gets exaggerated. One of the most important deep-sea adaptations is bioluminescence, the ability to produce light through internal chemical reactions. Light can be used to attract prey, confuse predators, signal mates, or vanish into the darkness through a trick called counter-illumination, where animals glow in a way that helps erase their silhouette from anything looking up. In other words, even light becomes camouflage. That is how extreme this world is. The one thing we usually think of as safety, visibility, and clarity becomes just another survival tool in a place designed to erase all three. This matters because bioluminescence is not a gimmick. In the deep ocean, it can mean feeding, camouflage, reproduction, or defense. Light itself becomes part of the food chain. The gulper eel looks unfinished, almost unreal. Its mouth is absurdly large compared with the rest of its body, as if the animal was designed around a single desperate idea. If something edible appears, swallow first and worry later. That strategy makes sense in the deep. You may not get many chances. Prey may be larger than expected. Energy is limited. So the gulper eel stretches the rules of what a body can look like, because normal proportions are less important than surviving the next meal gap. Its tail can even glow, turning the animal into another drifting ambush in the darkness. This is a recurring pattern down here. Deep-sea creatures often look impossible because they are solving impossible problems. None of these animals are weird by accident. Their bodies reflect specific pressures: scarce food, low light, cold temperatures, and crushing depth. Then the deep ocean becomes even stranger. The barreleye fish has one of the weirdest designs in the animal kingdom. A transparent head filled with fluid, with eyes that can rotate to track prey above it. It looks like science fiction, but that clear dome protects highly sensitive eyes adapted for darkness. In a place where a tiny trace of light or motion can mean food, vision becomes valuable enough to reshape the head itself. Every bizarre feature exists because down there, normal life gets punished. The deeper we go, the clearer the pattern becomes. The environment is driving the design. Not every deep-sea creature survives by attacking. The vampire squid lives in oxygen-poor waters, where many active hunters would struggle. Instead of acting like a relentless predator, it survives by being economical, drifting through darkness and feeding on marine snow, the constant fall of organic debris from above. Even its name is misleading. It sounds aggressive, but its real advantage is efficiency. It can turn itself inside out in a defensive display, revealing spiny-looking structures, but much of its survival depends on enduring low-energy conditions rather than actively hunting. The deep ocean is not only shaped by predation, it is also shaped by low oxygen, limited food, and the need to conserve energy over long periods. Deep-sea animals look extreme because the environment is extreme. Their bodies are responses to darkness, pressure, cold, low oxygen, and scarce food. Oversized mouths, glowing organs, transparent protection, and energy-saving hunting methods all make sense once you understand the conditions they evolved in. That is what makes the deep ocean so interesting. The animals may look unreal, but their adaptations are highly practical solutions to one of the harshest habitats on Earth. If you want more hidden worlds and extreme animal adaptations, subscribe to Hidden Wilds.